Now we will hand over to our co-founder, Bernd. Bernd will be presenting his talk on software architecture in banking and finance. Bernd, are you ready to take over and share your screen?
Yeah, I think so. Let's try. So here we go. Hello, everybody. That was the wrong button. Good afternoon, good morning, good night, whatever. I saw that we had people from basically all over the world, which is quite exciting for me, actually, to have you here. Great to have you. I want to talk about a bit about architecture. And I mean, there's probably a lot to talk about here. But I tried to make it crisp, and it's probably just a couple of inputs you might want to push further in your own company. And one thing which I think I don't have to explain any further is that this software is eating the world theme, which we see everywhere by now. So that was firstly coined in 2011, which is quite a while ago actually, by Mark Andreessen. And at that time, he wrote an article where he literally named it software is eating the world. And he basically described that everything is turning into software. So we are having less and less tangible items. So most companies are not producing a tangible item, but they're basically moving information from A to B, which is software, which is IT. And I totally remember times in the beginning actually of Camunda, we had meetings, for example, with the C-level executives of insurances. And I remember when we basically, in very nice words, but we basically told them, hey, you're an IT company. And at that time, there was really no understanding that an insurance company is an IT company. But that really changed. And especially if you're looking into banking, I mean, of course, somewhere there's probably still real money, but most of the things are simply information. And that was a very bold statement, for example, from Goldman Sachs, where he really said we're a tech company. And there are a couple of other things. For example, if you look at Goldman Sachs, there are then even statistics, how they changed their hiring, how they increased IT staff and developers and so on and so forth. So that's a big change, a big shift, a mindset shift we see in the industry. A good quote on that, which I like very much, is actually from Microsoft. When they acquired GitHub, they had the press release where it said, okay, every company is becoming a software company and developers are the center of digital transformation. Okay, choices these developers make will increasingly determine value creation and growth across every industry. And I think this core mindset is very important to have, especially in banking, finance, and insurance, but basically throughout most of the industry out there. One thing that also happens as kind of, let's say, as a consequence of that, because where software is much easier to disrupt, you have much more like competing business actually. On the very obvious thing is are all the startups, the fintechs or insurtechs or whatever you have, which start to eat part of your business probably. And I think for a lot of companies, probably even the bigger threat are the so-called big techs, so the Amazons and Googles, which starts to enter certain parts of the market. So just for example, if you look at payments or whatever. So basically you have a lot of these kind of threats and you have a very changing industry, and that's kind of the environment we're living in, and we need to maneuver. And one thing I like very much was actually, it was the CIO of a German insurance company. And he said to me, okay, hey, and that was very, very kind of, honest in a way. He said, we don't know what we will need tomorrow. We don't have the crystal ball where we can look into. So we also don't have that, but we need that something, we know that something changes tomorrow. And it might be a huge change. And my job is that I prepare the company to be ready for the change, to be able to move when we need to move. And I think this is the important mindset we need to have. And this is not a secret. I mean, that's quite in the open. But the big, and that's kind of about agility. So we had the big trend about agility, I think 10 years back when we talked about agile software development, basically. But that movement more looked at the single project. And now we're looking at kind of a business agility of, let's say, the whole company. And that's a huge topic, and I think it's important for survival, and it's a big part of the whole digital transformation discussion. The big problem is the contrast to what I see in real life. So if you look into a lot of our customers, a lot of prospects, or simply companies, for example, in finance and banking, you see very different things. And one of my favorite examples, and this is kind of a real life example, but it happens this way or the other. I would say at least I see that once a month. So very often actually. So let's simply assume you are tasked to build a new service, for example, to retrieve payments, right? Probably easy to imagine if you're in finance. So you should retrieve payments, but in this case, you probably don't do certain handlings like credit card handling yourself, but you want to leverage an already existing credit card handling service, probably in the internet, right? And now, one thing that you have to be aware of whenever you leverage like a cloud service, a SaaS service, something in the internet, you at least have to think about that service not being available, right? So that's actually a very important thing to remove the control. Sorry. So you at least have to think about that. And now, if you look at a lot of development teams, what they basically do, oh, we need to do a payment service. Yeah, this is a REST API. The REST API might not be available, but I need to collect the payment. So what could I do? Okay, I create a database table, and then I store the payments I need to take, probably with a status column. And then I know I still have an open payment. So for every payment I need to take, I basically create a new row here. Okay, then I have open payments. Yeah, of course, I add a scheduler, some kind of component that gets active, basically looks into the table and says, okay, I need to collect that payment. I do that. Then you can add some kind of retries and more resilience to the application. But then normally what happens is like you get additional requirements like, okay, but some payments might not be processed. So probably there's even something weird with the payment. So I need some kind of scripting solution in order to fix all of these. As soon as that happens, somebody comes around the corner and says, hey, if we have open payments, we need a report to see all pending payments and whatever, calculates risk or whatever they want to do. So as you can see, this kind of grows and grows and grows and grows. And I come back to that very example in the very end, and you probably already can guess that something like a workflow engine can probably solve some of the issues here. But still, this is something I see happening super often. And if you have this kind of architecture, this is not business agility as its best. So if you want to change something here, it's really hard to do because everything is like mingled together. A lot of things are hard coded. Probably nobody understands the whole architecture of that thing. Okay, so that's very, very problematic. The second example I have is, yeah, and I call that Wild West integration. It's kind of like, okay, I need to solve that payment now. I do it in whatever way I just have on my mind. I'm not looking at like the bigger picture and business agility. I just want to get it solved now, right? That's why I call it that way. The second example I have is batch. So you probably all know batch processing, and the metaphor I have for that is the elevator. And I mean, you know how an elevator works. So everybody queues up until the cabin basically arrives. Then everybody is packed and slammed into that one cabin, and then it moves everybody at the same time, right? That's an elevator. The way I describe that, you probably get the impression, for me, that's not a positive thing. I had, when I presented that metaphor at some talks, people are approaching me afterwards like, hey, an elevator is actually a very efficient thing to get people like to the right floor. And I said, yeah, probably. The moment I basically experienced that was last year at the conference. It was in New York. It was a skyscraper hotel, and I need to change to the next floor because the exhibition was in 2 floors, and I needed to take an elevator for that. And that was a horrible experience. I needed to wait for the cabin. It took a long time. I wanted to have stairs or an escalator or whatever. So that for me is the feeling of batch. And if we look again in a real life example, let's assume you want to adjust the credit limit for your bank account, like online. I want to transfer more money. Something you can do online with basically every bank now. So one way how you could implement that, and that's not totally uncommon actually to my experience, is like I could store that request somewhere in a database, right? And then I can create batches to process that. Like, for example, I could say the first step is I verify that the request is valid. And that could be one batch job, basically processing all the records, which are waiting, and then writing new records, which are verified. And then you have another batch, which takes all the verified records, adjusts the credit limit, and probably then you're done, right? So you need a couple of these batches in order to get going. And there are obvious downsides with that. So for example, if you have time-controlled batches, probably this is only done overnight. That's the experience a lot of people have with their banks. They can't do things online, but they have a delay of time. That's very often a batch. But the bigger problem I have here, and I come back to that a couple of times actually, is these batches, they're kind of orthogonal to the real workflow or the real process happening here. So the business process is basically, hey, I want to verify the request, I want to adjust the credit limit, and then I'm done, right? But you have these like batches, which are basically always like one activity in the real process, and that results in a lot of problems. So for example, you can't understand the overall process by looking at a single batch, because you need the chain of the different batches to understand the big picture. You can't easily change something. You have the time delays. If there's something wrong, so if you have an error while processing a certain request, probably the whole batch crashes and you can't easily restart it. You don't understand what specific record crashed the batch, and so on and so forth. And that's why it's totally not what I find business agility here again, right? So that's the big problem I have with these kind of batches. So that's what I see in real life. So that's far away from where we want to get to. So we could look at where we want to get to by looking at the big techs, for example. If they're attacking us and if they're doing something good, let's look at what they're doing. And there are a lot of stories about, this is Jeff Bezos, so the founder of Amazon. And there are a lot of stories about Jeff Bezos, but I like this one. And that's quite a while ago. They had issues, they had problems with scaling the company, basically. They were growing too fast, so a lot of things are not working out as planned, as intended. I mean, also Amazon has these kind of problems, of course. Right, and then they met at an offsite and basically discussing a couple of these problems. And then somebody basically said, okay, we need to improve the communication between the different teams, because most of the problems are basically the interfaces between different teams. And I think most of the people here can relate to that. That's a typical problem, right? As soon as two teams have to cooperate in order to get something done. So we have to improve this communication. And the interesting thing is the reaction. And Jeff, that's where like people were saying that groups need to communicate more. Jeff got up and said, no, communication is terrible. So he basically said, that's a problem. They need to communicate. That's a problem. We need to get to a state where some team can do something without talking to somebody else. And that was kind of the birth of what we now call microservices in a way. So instead of doing like monolith or bigger deployments where you mix a lot of functionality, you want to unbundle that and say, hey, I have a couple of independent services. And independent in that way, for me, mainly means I want to have them autonomous. And autonomous for me means there's one team caring about like one microservice. It's not I need two teams in order to deploy it. So there's no database team and business functionality team and UI team. No, it's one team which cares about one basically business capability or one business function, right? They have their own runtime, so they deploy on their own whatever, virtual container, hardware, whatever. So they don't have to coordinate that. They have their own database. They do, when they do a change, they do it on their own. That's the main idea of microservices. And that makes you faster because then you can apply changes within one microservice. That's I think, and that's where the industry is heading. And even if there are examples where people report about problems with microservices, I think overall for a bigger corporation, it's kind of the way to go. It's kind of makes a lot of sense to go at least into that direction, having that as a guiding principle. And if you don't like the term microservices, you could also relate it to APIs. For me, that's the important thing. So I have a business capability and that has an API. I don't care how it's deployed. I don't care how it's built. There's an API, there's a guarantee. And these might be microservices, but we have much more other components also which expose APIs, like external services, something hosted in the internet, cloud, SaaS. We have standard software, which probably already runs internally, and then they need to like provide an API. If they don't have an API, that's where these RPA bots come in. So we have RPA bots in order to basically provide the API for legacy software. If you're really modern, you do serverless functions, for example. So there are a lot of kind of smaller pieces you can do. And all of them provide some independent, basically business functionality. That looks easy on a slide. But the challenge now, and that's actually where I'm thinking about most at the moment, is like, how can I make sense out of these small components? Because normally if you do a bank account opening, if you do a whatever loan origination, if you do a whatever money transfer, normally you need a lot of these services to interact in order to get the job done. So how can I do that? Because then it's not like isolated autonomous, they need to talk to each other. And that's where the big complexity comes in nowadays. And that's the interesting part. If you're modern, and I'm not saying this I don't want to sound like this is a bad idea. That's totally not what I'm saying to you. I'm using that hipster metaphor in a couple of talks, and it works pretty well to stick. So that's what I'm using it. But I think it actually makes sense to go in a direction where you, for example, look at the reactive manifesto. It's quite old, but it's a good one, where it basically says if you want to have a responsive system, then these are basically two components which are important. You need to be elastic. So if there are more users, you need to scale out, and you need to be resilient. If something is broken in the system, the whole system should still work, should still respond, right? And the way to achieve that is mainly going message-driven. So not synchronous REST APIs, but probably message-driven, event-driven, if you will, nowadays. Let's do that. So that's probably also not news to you. So most companies I'm currently discussing with are doing at least some first steps, or probably even going all in with event buses. So things like Kafka, for example, are pretty hip. So the way it works, and this is a real-time, real-life example again. So I discussed that with a big bank actually for their account opening process. And they said, okay, we want to be event-driven. How could that look like? To give you an impression, if I have the customer registration here, and that's an own microservice, like autonomous, they basically just publish an event. And the event is like, hey, somebody wants to open up a bank account. That's the event, right? And in theory, this service don't care what happens next. It's just an event, they published it, they're done. But then, for example, the credit check service could say, I'm interested in that. If a registration is requested, I know that I need to do some kind of checks for that new customer, right? Then this service does it, and it basically publishes another event where it says, okay, the credit is checked or approved or whatever. It could be, there are a couple of nuances here, but it says the credit is checked. I'm done. And then there could be the next service like the address check saying, okay, if the credit is checked, I need to get active and do address check and probably publish another event. And the customer or customer onboarding or whatever the exact service is could say, okay, if the address is checked, I know I can really create the customer and probably publish another event. That's kind of the event-driven way of doing that. So it's obviously asynchronous here. That's good. And it's event-driven. So we're not the registration. Nobody's telling anybody else what to do. We're just publishing an event. And this is kind of a lot of people have the idea this is how you have to build an application in 2020. This is the way to go. That's the modern way. That's what you need to do. And that's kind of why I'm probably overusing the hipster picture for that, because I think it's not that easy. So, for example, if you do this, ask the question like, how does customer registration work? Like the overall process. And this is very, very much the same problem as you have with batch. You don't know. There's not a single point in the system where you can look at, this is how customer registration works. It works because there you have a couple of these event notifications, like you had a couple of these batches, but it's hard to understand like how it really works, right? I discussed that for ages with a lot of customers, and for quite a while there was a belief, no, that's the way to go. And I'm personally super happy that this blog post came out already in 2017, so it's not news anymore, but a lot of people might have missed it. And it's from Martin Fowler. So Martin Fowler, if you don't know him, he's quite a reputable source for knowledge. He wrote one of the most famous microservices articles, and he wrote in one blog post, he said, okay, you can do nicely decoupled systems with event notification, but the danger is that you don't realize that you're losing sight of a larger scale flow and thus set yourself up for trouble in future years. Exactly what I talked about with batch. If you don't understand how the overall process is actually working, it's that's not good at all, but it's also pretty hard to really change. The probably more funny part of phrasing that, I liked actually the talk from Phil Calando very much last year at the QCon in New York. He worked at Meetup at that time, and he had that slide. We are suffering from pinball machine architecture. And I made my own slide on pinball machine architecture. So if you have all these microservices and other services, and if you throw in like one event, basically what happens is that it somehow moves to the system. But it's really hard, I love that. It's really hard to understand how, right? And it emerges. Probably you change something here, and then the whole flow works differently without anybody really understanding that properly. So I think this is really a huge risk, right? You normally recognize that by what the hell just happened? How did that customer end up in that state? That's not possible in our system. These kind of problems start to emerge there. That's, by the way, one of the reasons, not the only one, but one of the reasons why we also invested in that, what we call process events monitoring, that you can, Felix had that very, very briefly at the end of his talk, where he showed that it can basically map certain events on an event bus, for example, onto a BPM and process model, and then do the same analysis using Camunda Optimize as you could do when it runs on a workflow engine. And that's, at least let's say, a starting point to understand the pinball machine, right? It's a starting point. But for me, that's like the first step. I think it's important, and it will help already a lot of people out there, but it gives you kind of the picture. Okay, this is how my pinball machine works. Okay, that looks nice. But now I want to move that stake. Only that one stake there. Only that stake needs to go on top. How hard can that be? And that's the projects we see so often. It's like you have these event flows, or I saw like a couple of startups starting with these event flows, and you just add components, you add a stick on top, and that's it. It feels super easy because you just react on a couple of events, and you add another microservice. You don't have to talk to other people, and it just works easily. But then you build up that system where you can't move any stick anymore, and that's, I think, the huge risk you have. What's the alternative? And that's, for me, totally obvious, probably for you as well, hopefully. The alternative is that, no, I don't go through that. You get the slides at the very end, but you can easily show, if you have this like scenario, if you want to change something, for example, and that was a real life example, if you want to add a new service, like to do additional checks, you have to adjust a couple of other microservices. So, and that's important. A lot of people think this is a totally decoupled architecture. It's like easy to change. It is not. It's not decoupled. You need to change a couple of services in order to get that working, right? So that's not easy, right? Let's get that. So this is typically called a choreography. You basically, and the picture normally you get when this is sold to you, it's kind of, hey, that's a beautiful dance. You have these microservices and they know how to behave. They somehow they get it done. You just add a new dance or a new microservice, it will be beautiful, right? That's what you see typically with the choreography and event-driven. And it's not what I see in real life with the products I've been with. So it probably starts easy, but it gets very chaotic. It gets very hard to manage after a while. So this is a big risk to be aware of. The alternative is what's called orchestration. And orchestration basically would mean that you probably still have events. And that's another misconception. It's not either or. You can have events like, hey, somebody wants to register for a new bank account. And then you, for example, have the customer onboarding service, like subscribing to that event, but then the customer onboarding coordinates others. Like it says, hey, first we do the credit check, wait for it to happen. Then we do the address check, wait for it to happen. And then we're done, something like that. So you have one component who really coordinate other components. And that's, for me, is one of the key ingredients in this architecture to really have something which yeah, is manageable and keeps being manageable. And then if you do changes, for example, you can do it easily within that like service. Of course, you can use BPMN for that. Of course, you can leverage a workflow engine for that. For me, that makes a lot of sense because, for example, if you're message driven, you could send out a message to the other service, hey, do the credit check now, and then wait for the event that this happens, right? And probably you decide to do the address check in parallel and wait for the event to happen. And if both happened, you do the whatever crime check and so on and so forth. So you have very much control over what you're doing there. You can wait for messages, and that's very, very powerful, right? And that's orchestration here. And one discussion I had there, and this seems to be a discussion I have really regularly, is people believe that event-driven systems are more decoupled than orchestration-driven systems. And I don't go into all the details. I wrote an article on InfoWorld. It's linked in the slides. But for exactly that example, I compared the changes you have to do for certain scenarios, and it's exactly the same. It's not that event-driven is less coupled. That's a myth, or probably even a lie. And that's important to be aware of. Probably if you have the discussion internally, that could help you. Let me make one more point here. So if you remember the payment example from the beginning, of course, you could also solve a couple of the challenges we had there with a workflow engine. Like, for example, as simple as a REST call for charging the credit card, that could already be a workflow where it can do the retrying, where it can wait for the other service to become available, where it can act if it doesn't become available. And then the workflow engine can help you implement basically one microservice much easier than you would do if you hard code it. Like what I said earlier on, you don't need database, no scheduler, and so on and so forth, because it can do a lot of things for you, right? And the important thought to have here, and that's basically the last one for today, is this workflow is kind of, let's say, an implementation detail of that microservice. So, for example, if you are in payment, you might have a microservice. You might have a workflow. If you are in an order fulfillment service, you might have a workflow. If you are in the customer onboarding, you might have a workflow. So every component can have its own workflow, and it doesn't have to be anything central. So a lot of people think of, there must be the central BPM thing. There must be these BPMN monoliths showing each and every aspect of that overall order fulfillment workflow. No, you want to cut that into the same pieces as you do with the microservices. Okay, I know that was quick. Sorry for that. There's much more. I'm talking about that a lot. So there are a couple of other talks if you want to dive into a couple of these details. They're linked there. I also have most of the stuff in code. So if you want to play around with the microservices, doing event-driven and these kind of things, go for it. Thank you very much.